Welcome back. Well, what better an application for chatGPT AI large language models than to build me a hearing test machine. In other words, an audiometer. One of those things, if you go to the audiometrist to get your hearing checked, they'll measure the threshold of your hearing. What is the threshold of your hearing? Well, before I actually go into what an audiometer is and what it does, first of all, a disclaimer, and that this is only for entertainment purposes. It's not a clinical piece of equipment. So, and it also, if you were going to use or do something like this, you need to do it at your own risk, because, if you don't calibrate your headphones properly, you're going to end up with large tones, into your ears, which isn't very nice for your hearing. Anyway, first of all, we need something to measure the level of sound. And the way we do that, of course, is a sound level meter. They've been around for a very long time. You can buy them, I noticed, in various sort of department stores nowadays, which has surprised me, maybe because of builders and so on need them, for the sound of saws and so on, to make sure safety levels are okay. So I noticed this one here, which I got, a really cheap one. This is in New Zealand, $35. That would probably be about 17 quid or something in the UK or something like that. US dollars as well, something around that price, or euros, I'm not sure exactly. It's not one of the best ones, but to get going, you need to have something. And I wasn't going to go out and buy a really expensive one, because I probably never really use it again. Now, absolute dBs should not be confused. dBA, in other words, should not be confused with the dBs that we use. If you're an electrical engineer like myself, we use dBs all the time. Like we say, reduce the gain by 6 dB or increase the gain by 6 dB, meaning double the amplitude of the signal coming out or whatever. And we plot frequency response in dB, amplitude in dB versus frequency, but that is not dB absolute. dB absolute is this sound pressure thing, which is international standard. And when you buy a machine, it's supposed to have been calibrated to that. And this is important that you do this. So it's important, first thing that we need to do is to be able to calibrate the headphones that we use with this hearing test machine, so that the sound doesn't damage our ears and we get within realistic ranges. I'll explain in a minute how you do that, but for dBs, here's the sort of level of dBs that's usually touted. So 0 dB, it's a person in a room, the softest sound a person can hear in a room, rather. That would be 0 dB. 10 dB is normal breathing, 20 dB is whispering at 5 feet away, and so on. So you get to 40 dB. That's an important one, because we're going to be using that. I should say 40 dBA, because here's dBA, because there is confusion, as I say, between dB and dB absolute. So these are dB absolute. So 40 dB would be a home computer fan, in a quiet office or residential area. 50 dB home air conditioning, 70 dB flushing toilet, and so on, up to a nightclub would be 110 dB if you took your sound meter along with you. 140 would be painful, and you do serious harm to your ears. Now, I ran into a problem here about a good 20 years ago when I was researching the so-called hum, which exists around the world, which is this low frequency noise that people hear, and that I give a graph out which was in dB. It was a frequency response of a sound that I picked up, but it wasn't in dBA, it was in dB, and it was intentionally in dB, because we electrical engineers, we use dB all the time for frequency response. But the newspaper that saw it, which was in London, I think it was the Times, they thought it was in dBA and started and just added a whole lot of things to the editorial saying how loud it would have been, which it wasn't. That was crazy. So dB that we use in electrical engineering is a relative measure. Output amplitude over input amplitude. 20 log to the base 10 of output over input in volts, or 10 log to the base 10 over a pressure. A power, not pressure, a power ratio, power out over power in. So we say we're reducing the voltage of the sine wave by 6 dB, and normally means I'm reducing its amplitude in half. So if it was, say, 1 volt peak to peak, I'd reduce it to 0.5 of a volt peak to peak, and that would be a 6 dB reduction, so on, or a 6 dB increase if it goes from 1 to 2. 20 dB would be a factor of 10, and so on. So don't confuse the two, because I'm talking about dBA here. I'm not talking about dB that we normally do in electrical engineering. So to the sound test, to the hearing test, what is the actual hearing test? So the hearing test is, I think I've got it here actually. So this is a very basic summary of it. It's how I started initially. I've been doing this for a good 5 or 6 weeks now, actually longer I think, on and off, because I was not very happy with it. But basically what you do is you play different frequencies. You start at a low frequency, about 250 hertz, and you work up to about 8 kilohertz, although you can go higher, and there's graphs are quoted higher than 8 kilohertz. They go up to like 20 kilohertz sometimes. For the normal hearing test, you don't go beyond 8 kilohertz or so, because that's all you need for your normal hearing. So we're not trying to test people to whether they're hi-fi buffs and whether they can hear, 18 kilohertz, whatever. That would be something different, and that doesn't concern us. This just wants to find out if you've got normal hearing or not. And you test each ear separately. Start with the left or whatever, and then do the right or whatever. So we started at a normal audible level. Now, the AI that was writing the program started at 100 dB, which was absolutely ridiculous. But that was dB absolute. And then what it does is it works its way down until you can't hear the tone anymore. So it goes in steps. So that's what we initially did. We started a higher level, and you just go down, and then you say, no, I can't hear it anymore. And so that's your threshold of hearing. You can't hear below that level of dB. Of course, you've got to calibrate things first before you do that. Otherwise, it just is meaningless, because every time you change the volume control, you've changed the whole settings. But then what you're supposed to do, though, to make it better, to get more accuracy, is once you've come down and this person can't hear it anymore, you then go up in amplitude. Once you go up in amplitude, and then the people will hear it again, and then you go back down again, and you can sort of go around in a loop and home in on the amplitude that the person can just hear and no more. And again, we did this similar sort of things very crudely when we were looking at the hum, me and a few colleagues over 20 years ago, but not at 250 hertz. We were going down at very low frequencies, which were outside the normal hearing range that you would test for. I'm not saying they're outside the normal hearing range, but they're outside the testing hearing range. We were going down at less than 50 hertz, which people don't normally need to be able to hear down there. So it doesn't really matter whether you can hear at 50 hertz or not. Although, of course, if you can hear down there, it can be a nuisance, because you can hear low frequency noises, which can be a nuisance to the person. So anyway, you do this. It's called the modified Hooks and Westlake approach, and it's been around, I think, for quite some time actually. I can't remember exactly when it was around. So this is what they use when you get your hearing tested. Now, you'll see these graphs around the internet of sound pressure, which is that's not it. Here, which is the standard file. So this is what it looks like. This is dB this is a logarithmic scale, goes up to 20 kilohertz. In this particular case, the test doesn't go up to 20 kilohertz, of course, and it's gone down to 20 hertz here. So this is just for a normal human with good hearing, normal hearing rather. So if you were listening, you could hear 20 hertz at 70. At 70 dB, you could hear 20 hertz. Let's say a normal person of all age groups, by the looks of it. So your low frequency hearing doesn't seem to degenerate with age. But as you go up in frequency, you don't hear these frequencies quite so well. So the threshold level goes down as you go up. So here at 5 kilohertz, a normal person can only hear, 10 dB or something like that before. And below that, you can't hear anything. So this area under here, you can't hear anything. You're kind of deaf to it. A normal human, that is. That's when the tone is right up at your ear, of course. It's not any distance away. If it's any distance away, it's different again, of course, because you're not going to be able to hear that even more. The sound level is going to be even lower. As you get older, past 2 kilohertz, the threshold of hearing gets worse. So there's a 60-year-old, of which I'm even older than that. So it's not looking good for me. But if you're a 20-year-old, you see it's not bad. And a 20-year-old can hear right up to, about 18 kilohertz. I know that some people will say they can hear 20 kilohertz, or some people claim they can hear above that. But that's really for hi-fi people, hi-fi buffs to argue about, rather than whether it's got any basis in scientific facts, another matter really. But so we're only interested in from about 250, which is there's 200 here. That's about around here somewhere. That's 200 up to 8 kilohertz. Here's 10 kilohertz. So to about here, that's about all we're interested in the hearing test. Okay. So I did a few versions of the program, which I'll show you in a minute. But then I found this from a paper, which was rather nice, which is a flow chart of how you do it. And I didn't actually implement this version because, again, I thought it was a little bit kind of tricky to do it automatically, because not tricky, but kind of dangerous, because if you've got somebody with not very good hearing, what happens is you start, let's say, at 40 dB absolute. And if you hear it, which most people would, of course, then you start going down and down and down. There's no problem. If you don't hear it, what it does is if you get no response, it increases it by 20 dB up to 60 dB. And it starts again, kind of thing, because your threshold is different from that's when you're hard of hearing. So instead, I started at 40 all the time, and just decreased by I think it was 15 dB and then 5 dB, and then started moving up again. Initially, we didn't. We just sort of came down. I say we, it's me and an AI. It's not me and another human here. So initially, we just went down by 5 dB and stopped. And then I decided to get a bit smarter and started going up again. But there was the question really is, how did the AI manage this, and how did it, did it work all right? And the answer to that is, yeah, kind of, because I used chatGPT 01 Mini to begin with, and although it did make some mistakes, it was easy to go back and correct them. But as you know, within the last couple of days, as I'm making this video, the full 01 is out now, and I don't mean the 01 Pro, which you pay $200 a month for. Again, at the time of making this. But the 01 version of ChatGPT, and I was actually able to feed it this, because it can now do images, and I was able to feed it this block diagram. And when I did that, I said, see, attach the modified method. Is this program following this properly? So I just said, the way we're doing it, is it the right way to do it? So this is the proper way to do it. And it says, no, the code as implemented does not strictly follow the exact method shown in. So it was able to read this flow chart which is incredible, really, I suppose, a machine, and work it all out and say, nah, you're not quite following it. So the starting level is fixed, is 40 dB, is what I was doing. And it's saying you normally increase it by 20 dB if you don't hear anything for those with hard of hearing. But I'm assuming that the people using this have got sort of some kind of hearing. They're not actually going to be clinically deaf or anything. So that's the case. So you would increase it and then decrease it. So it's not a huge difference. But nevertheless, I said to it, modify the code and, do it and just, relist it, which it did. And it made one minor mistake, which is a huge code. First of all, it did it and missed out a bit. It didn't miss it out deliberately. It actually missed it out and said, you can fill this code in because it's the same as the previous code, which means I've got to go back and look for the previous code and find that bit of code. And it's a very long program. So I said to it, no, don't do that. Just list the whole program. And it came out with an error, sorry, first time as well. Fixed that instantly. That wasn't a problem. And then I got it to do it. So anyway, ChatGPT 01 is very, very good for programming. And what I've read is that 01 Pro is slightly better. And there's a bit of an argument. I won't like to say because I haven't tried it. There's a bit of an argument going on as to whether 01 Pro is worth the money or not, really, or whether you should just stick with 01. But it is supposed to be better. So I think we've covered most of that. So now to the software. The software itself is here, and it's a long program with 1035 lines of code, which is, I don't know if that's the biggest, probably not the biggest one I've had so far done with AI, but it's still pretty big. One other thing, of course, I had to do, somebody had mentioned this in a comment actually in a previous video I did, was I had to make sure that the sine waves that I was generating finished on a zero crossing. Otherwise you get a clicking noise. And the trouble here is if you hear a clicking noise, often you can hear the clicking noise even though you can't actually hear the sound itself when it gets to a very low level. So that's not very clever. So I had to make sure it get it to change it on a zero crossing. So when you boot into the program, here it is. Here you enter your age. Let's see, 60. Let's see. You won't be able to hear anything here because it's the level's probably going to be too low unless you had headphones on. But the first thing you're going to want to do is calibrate. And so you don't have to do it from then on, but first of all, you calibrate. If you don't calibrate, you're asking for trouble. You just get totally meaningless results. And so what you do is you play the tone at, say, 250 hertz, 500 hertz, so on. Maybe I could play some of it. I don't know if you'll hear it. You probably hear that. I'll just put the microphone. You might get reverberation, a reflection when you hear this. That's 3 kilohertz. There's 1 kilohertz. So basically you play that out through your headphones and you put the sound level meter in and then you type, whatever, 55 dBs or whatever it comes up with at the various frequencies, and then you submit your calibration, and that's you done for that. That takes about 5-10 minutes or something. It doesn't take very long. And you just rest the sound level meter on the cup of the headphone. And then you start. Now I've put this in because otherwise the computer goes so fast that you can't work. I put a delay in. It's not absolutely ideal, but if you don't put any delay in, it thinks you're like a robot and it'll do the test really fast. So I put like 5 seconds. And then what that means is when you start the test, it'll play out a tone there at 250 hertz, and you need to press this button here. Click to see you heard it or not. So you see I heard it. So you're not supposed to be looking at this, of course, otherwise you've got an auditory feedback, and Because it's a trial thing, I had to put that in so I know what's going on. So it says user didn't respond there because I never clicked it. And then it goes down and down and down in level and so on. And then it moves on to the next frequency, and there's a progress bar along here which goes up and up. I don't want to do this on the video because there wouldn't be much point. It takes about 15-20 minutes, and it would be a little bit pointless, I think, to do this. It's just really showing you that it works. And I see that it's beginning to work now. I can hear it coming out of the thing. It's playing a tone. So I'll say I hear this. It's not calibrated to the speaker, so it doesn't mean anything anyway. So it plays the next tone, and I can't hear that. I just leave it. I wouldn't play it. It's moving on to 500. That was 500 hertz, by the way. I think it gave up at 250 hertz because I never responded, and it goes to 500, and then it goes to whatever, I don't know, 1 kilohertz or something, or 750. I can't remember, and so on and so forth. So anyway, that's the basic principle of it. It's still going. I'll stop it. So what did it actually give me out? So what it gave for me was this for the left ear. That according to this, I'm hearing impaired down at low frequencies. Then I'm not as good as standard. But according to the ChatGPT, this shouldn't be taken to be clinical, a proper thing. So until we got a proper audiometer and checked it off that, it doesn't really mean anything again. It's just an exercise that the machine can do such things really. And again, I'm off here by quite a huge amount according to this, 8 kilohertz. I'm virtually deaf up there. Because I'm hearing it. It's at 90. I've got to have 90 dBs. It says up there before I can hear. And according to this, a normal person can hear it about 55 dBs at 8 kilohertz. So whether that's true or not, I don't know. But my hearing isn't that bad really. But having said that, I haven't had it checked properly for a long time. And next time, if I do have to get it checked, I'll know exactly what they're doing. So that's the. This is the data that it gave out. It gives out when you finish. It gives you that information: 250 hertz, 500 hertz, 750, so on. And it gives you the threshold of hearing, and then you plot the graph, or you save it, and so on. The calibration data that you put in earlier is saved in a JSON file. It's called calibration data JSON, and it's stored with the program, and so you don't need to worry about that once you've actually done it the first time. So what I suggest you do there is you put the microphone volume up at maximum, just so there's a reference there. Otherwise, if it's like midway, you don't really know where midway is. So you stick it up at maximum, and then you do the calibration, and the calibration will tone it down. You're not listening through your ears when you calibrate. You're only putting the dBA meter on it, the sound pressure level meter on it, and that's how that works. So it just loads it in every time you do it then. Unfortunately, this isn't the first automatic audiometer meter. There's one on the market already, an expensive looking one with custom hardware even. I don't know whether you can do them online with just software. I doubt it very much, because again, clinically it probably wouldn't mean an awful lot, because the thing has to be calibrated properly. But I just thought you'd be interested in that, and again showing the power of AI to write these sorts of programs that it seems to be able to do. And the O1, which is just out, the version O for orange, that is, not 0, the 01, not the 01 Pro. It seems to be pretty damn good. I'd say as good as 01 Mini that we had, and if not better. It's the mistakes it's making are very minor mistakes. Okay, thank you very much indeed, and see you next time.